Hello there. Today is 15.1, day number 1, notes on the introduction of inverse trig functions. We're going to go ahead and just jump right in. We're going to talk about a lab in a little bit. It won't be tides related, it'll be daylight related. But if we jump into inverse trig right away, these two are very similar statements, right? For example here, if I want to know where the tangent of some angle theta, or x, equals 1, I would consult the unit circle, and it would be relatively easy for me to identify where that's true, right? If I have square root of 2 over 2 and square root of 2 over 2, sine over cosine in this case, would be, since those are the same, I would get an answer of x, right? This x, or what we could call theta, is equal to 45 degrees. Typically, this notation right here, with regards to its transition to that, would be a degree measure. Okay, so the inverse tangent will find you an angle. Okay, a similar notation with the same meaning would be arctangent of 1 is equal to x. Arctangent typically results in a radian measure instead of an angle measure. So arctangent equals radians, and inverse tangent, this tan negative 1, typically we use degrees. Now, if you're to mix those up, so be it, not a big deal. Okay, so I'd like to jump a little bit more into what this means, right? So if the cosine of 60 equals 1/2, that means the inverse cosine of 1/2 would equal 60. Or I could write it in an alternate form, arc cosine of 1/2 equals pi over 3. Okay, those are all equivalent statements. So we're jumping into this and getting used to this idea of what is an inverse trig function. So what is this actually asking? If it were a question, what would it be asking? What it would be is, what angle results in the cosine being equal to 1/2? Or another way to say it is, the cosine of what angle equals 1/2. Okay. All right, let's jump into and look a little bit further at another topic here. Okay, similar thing, right? Same transition, right? If I want to find out what this angle measure is, then I would do the inverse cosine of 1/2. Now on the unit circle, the inverse cosine, or the cosine equaling 1/2, happens in a couple of places, right? Here at pi over 3, and here at 5 pi over 3. Now, this isn't actually going to be an acceptable answer, and we'll talk about that in a minute. So pi over 3 will be our sole answer here. I'd like to skip down to the bottom of this page to look at a special example where we nest arc sine inside of a cosine. And now it looks complicated, but all that this is going to do is this is going to give us some angle. Now it's not a unit circle angle, right? Because 3/5 is not a ratio that we're used to seeing in the unit circle. So when we see something like that, or if you ever see an x involved, all right, then we're going to use the draw a triangle method. So what I'm going to do right now is I'm going to take, and because right here I see the sign is positive, I'm going to take this in the first quadrant. And I'm going to draw an angle that has a sine of 3/5. So let's call this angle theta. Okay, if I call that angle theta, then the sine of that angle would be opposite over hypotenuse. Using Pythagorean theorem, that would require this side to be 4. And so now I have all the sides of that triangle given theta. If I wanted the cosine, right, I'm just using this cosine right here. If I wanted the cosine of that angle, I take adjacent over hypotenuse, and I'm done. So the answer there would be 4/5. You don't ever even have to know the measure of that angle. It doesn't even matter. Okay, let's keep moving. All right, so I'm not going to get into this in its entirety in this video, but the inverse sine of x, but the graph of the inverse sine of x, is this on? This is on. The graph of the inverse sine of x is going to look like this. Okay, and we can talk further about this later, but the domain and the range are based on some special values of the function itself. So the domain of the inverse sine is -1 to 1, and the range of the sine is -π/2 to π/2. The reason that this is restricted, right? The sine, inverse sine would continue on looking like that, but then it wouldn't pass the vertical line test. So we're not going to continue with that. We're just going to restrict the range to -π/2 and π/2. Likewise with cosine, your calculator is restricted to this right here, where this is 1 and this is -1 and this is 0 and this right here is pi. So the range, the domain will be the same, -1 to 1. The range will be 0 to pi. Okay, I'll have a nice little graphic at the end of this to help you with that. Okay, the tangent is similar to sine in this way, other than the fact that its domain is all real numbers. You'll see that in a moment. Its range is similar to the sine, except it doesn't include those endpoints. And the reason why is because the vertical asymptotes that were at π/2 and -π/2 are now horizontal asymptotes, and the graph looks something like this. So it's interesting, the arctangent or inverse tangent has a non-restricted domain, but has horizontal asymptotes in two different places which restrict it. So let's get started here. I want to give you this visual real quick. When dealing with arcsine and arctan, and for that matter, inverse sine and inverse tangent, you're going to be dealing only with quadrant 1 and 4. When you're dealing with cosine, arc cosine, or inverse cosine, from 0 to pi, you're going to be dealing with 1 and 2, right? Because that's 0 and that's pi. And for the arcsine arctan, that's -π/2 and π/2. So what would the inverse sine of root 3/2 equal? Well, inverse sine is restricted to quadrants 1 and 4. I see a sine of root 3/2 here and here. Well, this one's in quadrant 2, so it's out. I want this value, so my answer could either be 60 or π/3. Okay, go ahead and try the next 3, and then we'll come back and check our answers. All right, so as we go through this, number 2, as you can see here, the cosine is -1/2 here and also down here. However, cosine is restricted to 1 and 2, quadrants 1 and 2, therefore this would not be the answer we want. You're never going to have an answer in that quadrant, ever. Well, I shouldn't say ever, in our chapter here. Tangent is 1. Tangent is +1 in quadrant 1 right here. Because if I took the sine and the cosine and divided them, I would get 1. All right, sine divided by cosine is tangent, therefore we get π/4. And then our sine of 1 is going to be right here at 90 or π/2. There's only one place for that. All right, let's keep going. Get on to a couple more difficult problems. Okay, here are some more interesting problems. This is not unit circle worthy. Right, I don't see that ratio in the unit circle, so I'm going to draw a triangle in quadrant 1. Right, inverse cosine is quadrants 1 and 2. And because it's positive, it has to be in quadrant 1. So I'd sketch myself a triangle. Cosine is 4/7. If I did Pythagorean theorem, 49 minus 16 is square root 33. So therefore, if this is some angle theta, then the sine of that angle would be opposite over hypotenuse. All right, let's do the same thing here. This angle, do a mental check, is in which quadrant? If you paused the video and came back, you'd know it's in quadrant 4 because the sine is negative in quadrant 4. Therefore, the sine is -1/3, which makes this the square root of 8. You could simplify if asked to, and therefore the tangent of this angle theta is opposite over hypotenuse. All right, let's try one more. Let's go with a different color here. This is a little bit funky. Cotangent of x, inverse cotangent of x. Well, which quadrant would we put that in? Since we don't know the value of x, we're going to put it in the first quadrant. The cotangent is adjacent or opposite. So if this is x over 1, we would have an x here and a 1 here. That would make, using Pythagorean theorem, our hypotenuse x squared plus 1, square root of that. This would be theta. So the cosine of theta would have to be equal to x over the square root of x squared plus 1. If you were asked to rationalize that function, you could multiply top and bottom times the square root of x squared plus 1, and you would get this. Either of these two answers would be acceptable. Okay, I'm going to move to a different page for a moment. I want to do one of these. Let's pick one out. Roll the dice, and yeah, let's go down here. Where is the arctangent, or what is, if we evaluated this, what would x equal? Well, that's asking me where in quadrants 1 and 4 is the tangent 0. Remember, tangent is sine over cosine. So that's asking me where is the sine equal to 0. I want to know where that's equal to 0 because regardless of the value there, I'm going to get 0 for our tangent. So where would that be the case? That would be the case here at 0 pi. So our answer would be x equals 0. 0 or 0 pi would work just fine. All right, let's try another one. One more. Where is the arc cosine -1? Well, arc cosine restricted to quadrants 1 and 2. Where would the cosine be -1? That would be right here at this point, -1, 0. And that location would be pi. So if that were x, x would equal pi. All right, let's get on to a couple more complicated questions. Here's a good one. Okay, so the arc sine of 5/4, draw a triangle. Quadrant 1, because I see my sine is positive. Where is the sine 5/4? Wait a minute. That's a tricky one. That doesn't exist. Why doesn't that exist? Because in no way, shape, or form should a leg ever be larger than the hypotenuse. Doesn't exist. Error, right? Error. Let's try another one. All right. Arc cosine of -1/2. Okay, so in the unit circle, in quadrant 1 or 2, where is the cosine -1/2? I would have to go with 2 pi over 3, right? I think we can all agree that that point would be -1/2 root 3 over 2. So if this evaluates to 2 pi over 3, what's the sine of 2 pi over 3? Sine of 2 pi over 3 would be root 3 over 2, right? It'd just be the y value right here. Awesome. All right, let's do one more. Let's go ahead and let's do number 174 right here. Okay, so here I've got myself a general case. I'm going to draw this general case in the first quadrant where the cosine is x over 5. That means that this would be 5 squared, which is 25. Whoa. X over 5. That means this side would be the square root of 25 minus x squared. Okay, so what is sine of that angle going to be? Well, the sine of that angle, of course, that angle is that acute angle there, would be the square root of 25 minus x squared over 5. All right, I want to do one more. Yeah, let's do 172 here. Okay, so first of all, I want you to identify something. This is cosine of 2 theta. Oops, I don't want that. 2 theta, right? 2 of some angle, and that angle is arctan of x, right? So that's theta. Let's sketch that. Quadrant 1, again, because this is the general case, I'm going to put it in quadrant 1. The tangent is opposite over adjacent. So I know the hypotenuse would be square root of x squared plus 1. So cosine of 2 theta, recall, is cosine squared theta minus sine squared theta. That's one of your identities. So let's talk about the cosine of theta real quick. That would be 1 over the square root of x squared plus 1. The sine of theta would be x over square root of x squared plus 1. So what if I squared those, right? What if I squared them? Well, what would happen to that denominator? The square root would go away. So cosine of 2 theta would equal, if I squared this first one, I get 1 squared over x squared plus 1. And in the second one, I'd get x squared over x squared plus 1. So what I get is 1 minus x squared, because I have a common denominator, over x squared plus 1. You think you might be able to factor that further, but you can't. Now, the one thing that someone's going to mess up here is they're not going to remember that this is a minus sign in between. So be careful. Please be careful. All right, folks, that's it for day number 1. Hope that goes well for you.